Example 1 on page 18 asks us to find the average rate of change that examines displacement or distance versus time. So the distance is going to go on our y-axis, and that's measured in meters. And versus time, so time is going to go on our x-axis, and that's measured in seconds. The question then goes on to tell us that at time 0, Jim is at 4 meters. So starts off, when he starts a stopwatch, he's at 4 meters. So we have one coordinate, or 1 point, 0 and 4. Then tells us that at 6 seconds, he is at a position that's 12 meters away from the wall. So we have another point that is 6 and 12. So if we connect those dots, we have a line which we can find the slope of. So the slope of a line can be found just using the simple slope equation. The slope is equal to y2 minus y1 over x2 minus x1. So in this case, we would have 12 minus 4 all over 6 minus 0. So that's 8/6, or 4/3 of a meter per second. So the average rate of change over that time frame is 4/3 of a meter per second. The second part of the question asks us to sketch a graph that might match this scenario. Now, there's really not enough information to sketch an accurate graph. All we know is that at some point in time, the graph has to go through those 2 points. So that simple, almost parabola could be an example of a graph which would match those 2 points. But so could just a straight line could be an example of a graph that would match those 2 points, or perhaps a more complex function such as this, where again we're crossing a point here and we're crossing a point here. Now, the technical term for a line that crosses a curve at 2 points, not always 2, it can be more than 2, is a secant. So this is a secant line to the graph which is sketched.